Welcome to Diving Deeper Discussions. I'm your host, Randy Isaac. I'm on behalf of the American Scientific Affiliation, and our focus here is on articles and book reviews that are printed in our journal of the ASA, the Perspectives on Science and Christian Faith. Today, we are here to discuss the September issue and the key article right now, which has to do with aquaculture. And it's a topic that most of us were not experts in. So we have a lot to learn today. We're very delighted to have with us Steve Hall and many of his team co-authors. I do think this is probably the longest list of co-authors we've had in any article published in the journal. At any rate, Steve, welcome to the program.
Thank you,
Randy.
There we go. Okay. Great to be here.
Yeah. Now, I know you've been with you've been with ASA for quite a while. We'll get to how that came about, but I think there are a lot of people here in the program that don't know you that well, other than your team. So let's find out a little bit about you, and then we'll talk to your team a little bit later. So I know you were somewhere else for a long time, but where were you born and raised?
Actually, I'm from upstate New York, Finger Lakes area.
Oh, really?
Yeah.
Great area to be from. Yeah. Close to Cornell, Ithaca?
Yeah, Geneva, New York, and I did spend some time in Ithaca and Buffalo for 7 years. So yeah, I know the football culture as well. Yeah.
I was going to say, do you, did that make you a Bills fan?
Well, you can't not be a Bills fan in Western New York. Yeah,
I thought so. I don't know if you hung on to that, but you probably, had a bad day last week, though. But maybe we'll get through.
Not the first.
No, it won't be the first. Okay. So, all right. So, tell us a little bit about your education. Where'd you go to school?
Yeah. So I actually got my undergrad in University of Buffalo, mechanical engineering. I'm licensed as a mechanical engineer in New York State. Have maintained that and have been licensed in some other states. Eventually did a graduate degree at UC Davis and a PhD at Cornell, postdoc at Yale.
All right.
You moved around a bit. To LSU, which has a little football team of their own down there.
I think some of us may have heard of it. Yeah, that's all right.
And moved up to North Carolina about 8 years ago. So now I'm a North Carolina boy. Yeah.
How long were you at LSU?
17 years. Yeah.
Okay.
I see Jay Holman. Do we have any?
Yeah, I was going to say we got Jay out there.
Daniel's there. Yeah.
Okay. Cool. Yeah, it's got some things. Yeah. So what made you move to North Carolina?
So I'm very happy to have been invited by a former student of all things to take a position as director of the Marine Aquaculture Research Center. Been here about 8 years, and so the co-authors are mostly colleagues, some of them former students, and I think we have Louisiana and North Carolina connections and international connections. So yeah.
Cool, that's great. Okay, we'll get to your team in just a minute, but let's talk a little bit about how you got to this point. What was your faith background? How did you learn about the ASA? How'd you come to be a part of it? How'd that happen?
Yeah, seems like there was some kind of book guy from InterVarsity that twisted my arm at one point, and a little bit later, Jay Holman, who's on the call, was a great mentor and encourager. So it's been a really great walk, talking about the ways that our Christian faith and our scientific walk can not just coexist, but encourage each other. And that's the ASA has been a great place for really good conversations and personal development, and really thankful.
Do you remember when you joined?
Actually, I think it was back in the early 90s. Yeah.
All right. So it's been a while. Oh, that's great. So I guess the interest in this particular topic of this article is fairly obvious if you went to North Carolina to be responsible for the program. So that's rather interesting. So at this point, let's pull in your team. So Becky, if you can open up the microphone so that the team members who happen to join are able to unmute themselves. And Steve, I wondered if you could call
I'll just call on you
each of them.
In the order that I see you on my screen. So Vashti, you're the first on my screen. So just introduce yourself briefly, who you are, and a little bit of your expertise.
Hi, everybody. My name is Vashti Campbell. I'm a former student of Steve's. Funny, we met at LSU. I was doing my master's at LSU. So I got my undergrad from Norfolk State University in chemistry, my master's degree in bio and ag engineering at LSU. And I met Dr. Hall right before he left. And even the way I got to North Carolina State is just a blessing. But I didn't know he was there, and ended up working under him and getting my PhD under him in 2022 in bio and ag engineering. So it's been a treasure just to write with the whole team and be able to just talk about God through science.
And Vashti's in DC with engineering consulting firm now.
Yes.
Food process, food safety. Yeah.
Yes. So I work for Exponent. I'm a consultant there in their food safety group. So anytime something goes wrong, our team is on it. We get called by attorneys and insurance people. So it's been pretty good. I've been there for about 2 years now. So, yep. Thank y'all for having me.
Okay, Matt Campbell. Okay, we got the Campbell twins. Matt's the next one on my screen. Yep.
Steve, great to be here. So Steve and I go back pretty far, back to when I was at LSU as an undergrad, and he was a brand new professor trying to figure all of that out. And from day one, we were talking about this topic of how we're mandated to steward the world, steward the earth, steward creation. And that really shaped a lot of the way I thought about the way I approached my vocation. And so I went on to do other things, but Steve and I always kept in touch. And I guess it was back in 2015, I was actually making a transition in my career. I had been working in consulting and I wanted to do something different. And that's when this topic came back up again. He said, I'm starting to put together this paper. And then we started to work out some of those ideas that we had talked about over the years. And at the same time decided I was going to go back to school. So I went back for my PhD in biological engineering at NC State. And so I actually followed him up there and we got to talk about this a lot more. And in the meantime, I started a business, technology business focused on ocean restoration. And so while I continued to work on the aquaculture for food production, at the same time, I was working on aquaculture for ocean restoration. And so a lot of these things kind of came together in that, and really has been formative of even how we approach our business, the way that we're approaching projects globally now on this with that worldview in mind. That definitely has been shaped working through this over many, many years.
Okay. Thanks, Matt. I have Daniel next on my screen.
Hi, good morning, or good afternoon, I guess, everyone. I'm Daniel Smith. I have a bachelor's degree in electrical and computer engineering, and then a master's in biological and agricultural, and a PhD in biological from LSU. I was Steve's last PhD student at LSU, and actually finished after he had moved to North Carolina State. But Steve and I met in
99. Yeah.
99 when you came to LSU. I was actually on staff in the department there as their computer systems manager, and spec'd out Steve's first computer for him, and we became friends through that interaction. And then we had a small group that met there in the department for a while with Steve and some of the other grad students and staff members. So that's kind of how we met. And then when I decided to go back to school in 2006, They were doing some interesting research with autonomous vehicles. And so, excuse me, that's what I went back to work with. And so that's kind of my area of focus is autonomous vehicles applied to these environmental and aquaculture problems.
Thanks, Daniel. And Chris, you're next on my screen.
Yes, hello everyone. Good afternoon. I am Christopher Pascual. So I'm from the Philippines, and I'm a PhD student under Dr. Hall's mentorship. So I came across with Dr. Hall back in 2022 when I was looking for a professor who could, mentor me in my interest on aquaponics, vertical farming. So back home in the Philippines, I'm working in a university where I do lecture, research, and extension, the same way as Dr. Hall is doing here at NC State. And so at first, I applied for many universities and I have an admission from Ohio State University first. But then I said, I keep on finding another option. So I came across with Dr. Hall, and true enough, coming here at NC State is, I would say, a blessing for me because not just the mentorship in terms of academic that Dr. Hall is giving me, as well as in terms of emotional and spiritual uplifting that I'm getting from him. So it's more than worth enough that I came here, and it's truly, I would say, God's will that I landed at NC State University. And so yeah, so my research interest is mostly on sustainable agriculture. Specifically, now I'm doing aquaponics, and we twisted it a little bit, digging deeper into some opportunities doing marine aquaponics, which is not usually being done. And so, because there's so much opportunity in marine aquaculture and aquaponics, combination of those two. So yeah, we are doing so much great and fun in the research that we are doing, and we believe that this kind of research and initiatives will be big in the future as related to food production system and taking care of our environment at the same time producing more food in a more sustainable way. So I'm just glad that I'm with this team, and yeah, thank you so much for having me.
I think that's it for co-authors.
That's it.
right
Okay,
now.
that's great. Got everything in there. All right. So as we begin our discussion, it's somewhat at the suggestion of Del Kuhn. Steve provided a nice video that about 2 minutes that can help set the stage for this discussion and the whole article.
The spirit of adventure is unquenched. The crew of the fishing smack brings news of giant octopus nearby.
By 2030, 2/3 of our global seafood requirements could come from aquaculture. As seafood consumption increases, sustainable aquaculture must keep up with the demand.
For safety net, sustainable aquaculture means only catching the right fish. If you're catching the wrong fish and you don't want them, they tend to get thrown back, and that can really damage fish stocks. It puts pressure on food security because it means that we don't have enough fish or biodiversity left in the oceans.
We build devices that help fishermen fish in a really sustainable way to help preserve ocean species.
By emitting light that can attract and repel different species of fish.
We can work with the fishermen to tune their nets so that they can catch the fish they want, and the fish they don't want to catch can swim away.
So we do a lot of aquaculture research at SAMS. I study microalgae and looking at how we can use different species of microalgae to improve feed stocks, nutrient bioremediation, and for the aquaculture industry as a whole.
Producing a fillet of fish for us to eat leads to a lot of byproducts that often are wasted. We can make high quality, tasty products from these raw materials using proper processing technologies and techniques.
We really have a chance here to build a more sustainable food system in Europe. Aquaculture has, in our opinion, a clear role to play. It's able to produce healthy, safe, tasty and affordable food.
I only want to prove that for-profit businesses can solve real global problems and actually show that they're creating value.
And I suppose for appropriateness, ASA and our group do not officially advocate for any of those companies, but the idea of the general idea of aquaculture as a very fast-growing industry, and I liked it that it had a little bit of diversity, a little bit of technology, but also the idea that there's plants and animals in aquaculture. That at least gets us a taste of what aquaculture, but that industry, we now eat more seafood products from aquaculture than we do from the ocean. And so as the one speaker there said, it's likely that it'll be 2 to 1 in the next decade or two.
Well, Steve, how fast has that grown? Like,
It's been
what was
growing
it?
at about 6% per year for the last 50 years. So it is quite an ongoing curve. And obviously anything that gets big can have negative impacts, but at the same time, we believe that at least some of the positive impacts are sufficient that we would want to tackle those. So that's part of what we're working on.
Yeah. Okay, so as we normally do in our program, we're going to start with the questions submitted in advance. And Dal, you were the first one here. Why don't you unmute yourself and ask your question?
Hey, Brandy, Steve, thanks for the article. Thanks for the video. I'm a visual person, and 2 minutes of a video beats reading. Beats reading a long article. Anyway, I managed to sneak in 2 questions that Randy didn't catch, but the first one is, are there particular species being overfished that have targets for specific species reduction? And then the second one, are those targets something that would be worthwhile for an aquaculture company to go after as an idea of replacing the demand for those overfished species? And I'm not trying to get any marketing plans from any of your co-authors. It's a generic question.
Yeah. So basically the idea that many of our species, depending on who you talk to, 35% or up to 85% of the fisheries are at some amount of decreased productivity. Just as a local example, one of the fisheries a couple years ago was reduced. So this is in places where things are managed, as in much of the United States or Europe. What they do is they shorten the season. So they had shortened the season for one of our big species to 6 days out of 365. That's almost the same as saying you're really not catching those fish. Now you can catch some of them and maybe put some of them in the freezer and sell them a little later. But the point is there is 359 days when some other product, perhaps produced by aquaculture, could certainly compete or be of interest. And that's just one example, but I think that trend is there. We're working on a species called striped bass, Morones excitalis, as one example. Some people call it rockfish. It's a popular East Coast Atlantic fish. We now have a domesticated species, and there are people growing this commercially. So yes, some people and some species. So there are target species people are working on. It's harder than it looks. So on land, according to Jared Diamond, 14 species were domesticated by 2000 BC. Everything you're thinking of, chickens and pigs and cows, and a few things you're not thinking of, like camels and ducks and guinea pigs. But 4,000 years is a long time to select and get used to how you grow them. aquaculture is roughly 50 years old. So we're in generation 8 as an example on striped bass in terms of our genetics. So it's a very new phenomena. It's a lot of work.
Well, Steve, can you help explain a bit what you mean by domesticating fish? I mean,
Yeah.
I'm going to cuddle them and have them feeding. So what does it mean? How do you do that?
Yeah. So what's a domesticated species? And I mean, this is almost philosophical as well as biological. But you want to be able to put them in a controlled environment where they will grow well. And wild animals notoriously do not fit that bill. We sometimes put some wild animals in the zoo, and frankly, it's really hard, even with lots of money and effort, to grow a few of them. But a food animal, you want to grow a flock of chickens, not 1 or 2 chickens. You want to grow a tank full, a pond full of fish, not a handful. And so it's actually really hard to do that. So yeah, I think that's part of it. The domestication is selection over generations to look for animals that will grow fast and grow well in captivity. Matt, I think, has a comment there.
Yeah, thanks, Steve. I was just going to add on to that. We discussed it in the paper, but this idea of raising tigers versus cows. So when you think about what we've done on land, we don't raise tigers. It wouldn't make any sense to raise tigers. I know some people do, but really we raise cows. And part of that reason is it is more sustainable to go out and feed them grass. And so a number of aquaculture groups are looking at species that are herbivores. So cereal, some other species that you can feed algae and other things, and you don't have to have fish meal. And when you look at the bycatch and all of this that's going into fish meal, it's actually quite substantial. And from a sustainability perspective, if we can move more closer down the trophic levels, that's going to be something that's a lot more sustainable. So yeah, thanks, Steve.
Yeah, thanks, Matt.
Remembering that.
Again, the more you're discussing it, the more I'm understanding a topic that was a complete blank to me. And I again, really appreciate you bringing this to the fore, and at least to my own mind.
Thanks, Tim.
All right. Jay, you're next.
Well, I'm glad you have somebody there also from the Philippines, because one of the things that we think a lot about nowadays is the declining replacement populations of Europe, of China, of Japan. The United States still seems to be growing and will continue to grow. But, it's nice we have salmon farms in Norway, and we have this developed. But the places that are going to grow are in Central and Southern Africa and in South Asia. China is actually going to, supposedly, the population is going to decrease even to less than 700 million by the 2100. So it would seem to me that this technology is going to be most useful, or if you're going to try to do things, you ought to be doing it in the Congo, in Ethiopia, in Bangladesh, in India. Is any of this being done?
And Philippines? Yes. Yeah, no, great question. And Chris may have some additional comments, but we have colleagues in Africa and Asia. India is, in fact, a substantial producer of fish for their own consumption, but also for some amount of export. The U.S. is a net importer of seafood products to the tune of about $17 billion a year. So we actually could probably stand to grow a few more fish here. But yes, how do we grow enough fish to provide food security in many of these places where they have substantial populations, where they need that protein? And so it's interesting. I often talk about the fish that are going to feed the world and the fish that pay the bills. You'd like some overlap there. But the fish that feed the world are things like tilapia, which is an African fish and grows very well, catfish. And there are different varieties of catfish around the world. And so those type of species, carp is extremely popular in India and the Indian subcontinent. grown usually in ponds. So they're very productive and they're deep into the interactions of how do we do this better, more efficiently, because they're well aware that they need to produce that as well. So, and then we have one of my colleagues was in Bangladesh here recently. Obviously, Chris, represents the Philippines. He's on pretty much every day talking to someone in the Philippines. So there's definitely conversation going on there and training that's going on, really building that human capital to be able to do that in the places where those populations are growing. So yeah, thanks. That's a great question and really important.
Okay, good. Thank you. Okay, so those are the only two questions submitted in advance, unless somebody submitted them too late for me to see it. At this point, I want to open it for discussion.
I had a second question.
Oh, you did?
Yes.
I didn't see that. Well, I'm glad you jumped in. Okay, go ahead. After that, I'll just say that our usual protocol, if you haven't been on the program before, is go down to the reaction icon and click on that, and you'll see a raise hand option. And as you raise hand, I'll call on you later in the order in which you raise your hand. Okay? All right, go ahead, Jay.
Steve, when we were working on a book together a long time ago, we were talking about the algae blooms and the toxic effects in the Gulf and how big is the Gulf dead zone. And I was surprised to learn that before the bloom becomes toxic, it actually results in an increase in seafood because there's more food to eat. And how is there a way to do that, to control that? And then, of course, others, I think there's some billionaire or some millionaire trying to grow algae and or different that will not be used for food, but to go down to the bottom of the ocean and to sequester CO2. Are you involved in any of that, or does that any of that make sense?
Yeah. So again, a great question of essentially, you're really asking more than one question. One of them is if you have eutrophication from nutrients, nitrogen, phosphorus, then you will tend to grow more algae. What do you do with those? And then a second question, which is, can you sequester some of that carbon? And I'm going to hunt this a little bit to Matt and or Vashti to tackle a little bit about oysters, because I think oysters, even though you're talking about algae, oysters eat algae. So I see Matt ready to talk.
Yeah, I mean, this is something that we talked about at NOAA a good bit of, sometimes these algae blooms will turn toxic, and they don't really know why in a lot of ways. They know that it's nutrient driven. There's some current aspects to it, but I think there probably needs to be more study on those blooms and how they transform before we could actually control them. But to Steve's point, one thing that we can do is add more filter feeders to the system, which are cleaning that water, transforming those nutrients into other bioavailable sources for the worms and other things that are going into other places in the food web. And we've done a lot of work with just putting more substrate out in the bays and estuaries for these oysters to grow on. And one single oyster can filter 50 gallons a day. And so when you start looking at whole beds of these oysters, they can filter a massive amount of water and take some of these algae out of the water column that could potentially turn toxic or cause eutrophication.
Yeah, and once they clean the water, you can clean the oysters. There are different systems. One of the systems I did my research on is depuration, where you can take an oyster from a contaminated body of water and put it in a clean body of water, allow it to resume its natural filtering process and kind of purge itself of any contaminants. And from there, you can take that oyster and eat it. And often they might use the shells to build like barrier reefs. So the whole thing with oysters and other filter feeders is very sustainable and helpful to the environment.
Well, thank you. Yeah.
Okay. Is that it, Jay? All right. Okay.
He didn't talk about sequestering.
Okay.
How do could you have big seaweed farms and then just cut them down and let them flop in the bottom of the ocean?
Right.
And
So we actually have had pretty substantial discussions on this. So in theory, some biomass that falls to the bottom of the ocean goes in the anoxic zones and stacks up and becomes essentially sequestered down there. In practice, that's a little harder because this material is often in the water column, so it tends to break down again and then re-release that carbon. The filter feeders like oysters are actually really great at sequestering some of that in the meat, which then becomes a useful product for human beings or other animals. And then some of it in the shell. The shell of these bivalves is calcium carbonate. It's about 13% carbon by mass. And the other thing about those is they stick around for a while. They last for many years. And if they get down in the anoxic zone, slowly sinking, they'll also get stored down there. So yeah, there are a lot of people talking about these. I think sometimes people don't think enough about the fact that there's a time factor here. You have to sequester things for long periods of time. But it's a great concept. And then I think our feeling is that oysters are a nice, and other bivalve species can be very nice as a sort of intermediate that gives you both food and some of these environmental benefits.
Okay. All right. So let's move on. First raised hand I see was Terry Gray. Come on, Terry.
Hi. Thank you for your papers, yours, many of you, paper. I have a question that might be a little off the beaten track, and maybe even a little controversial or shocking. So it's sort of got two parts. One is, in my research and my studies, I've come to realize that 95% of mammals are either humans or agricultural. And there's just a small percentage of wild and with birds, it's like 75%. So 75% of the bird population are chickens and ducks and geese and things that we use for food. And I'm just, wondering, have you thought about the way that's happening or might happen with respect to aquaculture and these fish populations and oyster populations and so on, and that these things are all will become domesticated and vastly reduce the sort of diversity and biodiversity of that natural environment. And then if I can throw in a second question that's, I think, closely related, many people, speaking of this biodiversity decrease that is sort of happening and will begin to happen even more in the oceans as we farm them, I think, people are talking about there being another mass extinction of life on Earth caused by human influences and perhaps agricultural practices and the like. And I could probably make the same arguments with plants. But the shocking question that I want to throw out there is so what with respect to mass extinctions? Suppose we replace much of the ocean life with aquaculture, obviously reducing the biodiversity and so on. But is that really, other than maybe the aesthetic value of having a biodiversity, is there really a serious problem that's serious, even more serious or serious. We seem to be managing it okay with the life with agriculture in its various forms. Anyway, just throw out that question.
Okay.
As
Thank you.
the farming of the oceans was a theme, it seemed to me that that's a relevant question.
Okay. Matt, are you raising your hand in response to this question or a separate issue?
I am. I would love to tackle this one, but if Steve wants to take a shot first, I'll let him. This is why I came here. This is a challenging one. Thank you, Terry. So there's some really interesting parallels between land and ocean, but the world is 70% ocean or 70% water. And so when we're trying to do agriculture on land, we're working with a smaller area, and a lot of the areas where we have agricultural based lands, we've had to clear out, some natural forest and other type prairie land and other things. In the ocean, it's a desert, mainly a desert with a few oases. And so when you end up putting these aquaculture facilities out there, they actually end up creating habitat. So then you start having all of these smaller fish come around. One of the biggest concerns of aquaculturists is, having seals and other things come in and act as predators, and sharks, because they're attracting this other biodiversity that's coming around. And as and I think there is a question of like siting. How do we site these aquaculture facilities? Do we go into areas that are protected like we have with some of the salmon farms? And what does that have an effect on the environment where you don't have as good circulation? But then there's other companies that are, saying, well, what happens if we go out to the middle of the ocean where there's less impact? So I think there's some really interesting questions there around how can we not just be, how can we be restorative in the way that we do aquaculture? And I think some of the land-based agriculture is starting to do that as well. So you see regenerative agriculture, you're starting to see a lot more where they're introducing other species as a ecosystem-based approach to agriculture. Now that's on the small scale, but I think it has implications on what we can do at the larger scale with alternative grazing and things like that. So I don't know if that completely answers your question, but those are definitely some thoughts that I've had as we've dug into aquaculture. And, with my job now is how do we restore the ocean? I think some of these things definitely come together. So, Steve or others, I don't know if you had some additional comments.
Yeah, thanks, Matt. Yeah, I guess I would just maybe add briefly. I mean, I think there is some reality to what Terry's talking about, that, famously on land, humans and what humans eat is the predominant sort of biomass of mammal and bird species. And that could happen. I think there's an ethical balance here. On the one side, are we willing? Do we want to? If we are capable of feeding 8, 9, 10 billion people, should we do it? And for myself, I feel like, well, if we can, then yes. I don't want to be starving people. On the other hand, I think there is the fact that, well, it takes space, it takes resources, it takes energy to grow anything, even the efficient things. And we've talked a lot about maybe some of the plants and some of the filter feeders are more efficient and more effective, but how do we do that? And that, I'm not saying there's an easy answer. I think there's some real conflict here. I really like what Matt's doing, and Chris's work with aquaponics, I think, is another kind of angle on this. And maybe Chris, I don't know if you'd be willing to say, just to give us maybe a 1-minute commentary on aquaponics, and just how that maybe adds some value to the aquaculture overall. You're still muted.
Yeah, sure. I think what we are doing with aquaponics actually is we're trying to combine the production of, aquaculture and hydroponics, where we are producing plants and fish at the same time. Because as we know, fish in aquaculture side, we are producing also a nutrient loaded waste. That nutrient loaded waste could consume or could be utilized as a direct fertilizer for the plants that we grow. And so this idea of aquaponics is, it's been there already. It's there has been a natural settings that has been recorded way back in 1500 BC from China up to Mexico and some other places in the world. And then now that's more of a natural systems. But now we are trying to, the modern system is we are trying to introduce some modern systems wherein we can actually house the fish and the plants at the same time and grow them, developing a symbiotic relationship between those plants and the fish, while reducing the impact of wastewater production that can be drive into the open waters that can cause algal blooms and so this is some of the initiatives of aquaponics that we are trying to do. And by the way, going back, maybe uh, I believe that aquaculture, the fish farming, is complementary to what is the wild farming or wild fish catching in the ocean. We are not actually destroying or reducing the ecosystem or the diversity in the ocean, but what we are doing with aquaculture is we are complementing the uh, the lack. The because it's no longer enough for the open catch to produce the food that's needed by the increasing population, and so we are doing this aquaculture. So it's much, I would say, it's more on the complementary rather than discouraging or damaging the diversity in the ocean.
So if I could just interject, it's kind of a follow-up question, but you know, we're only a few generations in this process, whereas in, you know, our bird agriculture and our mammal agriculture, we're, you know, millennia in the process. And so, you know, I guess, you know, the optimism that you're painting with respect to maintaining natural biodiversity in the ocean when we're starting to use this for these aquacultural purposes seems a little premature. That if we were to have a millennia or two of aquaculture, would we, you know, I don't know that I necessarily want to say mess up the ocean the way we've messed up our terrestrial systems, but you see the idea that I'm exploring there.
I do. I think the question, I guess the assumption in your question too, is that agriculture has decreased biodiversity on the terrestrial side.
Well, just in terms of the 95% biomass that is attributable to humans and to our agricultural products, it seems to me that that's sort of a natural follow-up.
But Terry, we can't really do the opposite experiment of saying what would biodiversity be if we hadn't had any land culture. Would it really have? You know?
We can't do the experiment, but we can certainly see the historical trend of, you know, cows.
Yeah, but I just may saying may not be the source of having, held down the wild population. You know what I mean? It could be we simply increase this portion, all right, in a disproportionate way, but we may not. Although I think we actually did, but I mean, it doesn't necessarily push out the wild. right?
Well, I mean, our extinction patterns, the extinction patterns that we're observing in the modern, in the sort of human era, suggest otherwise.
Okay.
Well, I'll give
Fair
you an
enough.
example in the ocean. What happens when you don't have aquaculture is people have to eat. And so they're going to try to get it the best way they can. And so then you move from fishing poles to nets to bigger nets to dynamite to all kinds of things that are extremely destructive. Whereas if you can take the pressure off of the wild fisheries, because people are going to have to eat, and you move that towards aquaculture, then people aren't going to be doing those destructive things as much anymore. And it allows those systems to bounce back. So to Randy's point, if we weren't doing agriculture, would we be out there killing every animal that we can find and really destroying the environment if we didn't have agriculture, which is much easier to do than run around the forest?
Yeah, good. Okay, let's move on. Fred?
Yeah, hey, I'm really enjoying this. I was a commercial fisherman back in 1972 and 73 in Alaska.
Where? Alaska?
Salmon fishing, and we cheated by having quarter-mile long nets, Matt. So that's not the longest net, but I want to follow up on what you're doing on oysters. I take it you're down in an area where you can put oysters, like in the Chesapeake Bay or things like that. And let's hear more about the success of that.
Who's taking that one?
Matt's going to take that.
Okay.
Okay, I'll take it. I don't want to dominate, so
that's all right. Go ahead.
But yeah, we're putting out substrate in a lot of areas that already have decent growth, and so oysters, they are mass spawners. So they put their eggs out into the water column, and then they blow, and then they attach to something. But if they don't have anything to attach to, they won't survive. And so we're putting out lots of substrate in different configurations in places where we know they will grow. We're having huge success, and it's really interesting. The Chesapeake Bay has had these programs in place through the Chesapeake Bay Act to clean up the bay and reduce nutrient loading and sediment loading into the bay. But they've really come on strong with putting more oysters out there. And they know because they clean up the bays. And so there are now you can get credits for actually putting oysters out in the bay. So there's a way to calculate how much that's worth from a TMDL or total maximum daily load mitigation standpoint. So if someone's doing a development and they have to mitigate the nutrients that they're putting into the bay, they can actually buy a credit that may have come from an oyster that's placed out there. So it's really interesting that market is developing, but it provides a way to clean up the water. And I'll just say we had a project where we put out it was a shoreline protection, but it had oysters incorporated into it. And within 9 months, the whole structure was completely covered in oysters. We went out there to inspect it, and the guy that I was with, as a fisherman his whole life in that area, contractor, and we pulled out this huge horseshoe crab right behind the structure. He said, "Wow, I've never seen that in this area my whole life." And so as we're restoring these environments, I think that we are going to get more biodiversity, more fisheries within that. And we've been able to see it in a fairly short amount of time.
Well, I can think of 2 ways that I could help you out with that. First of all, I'd love to come visit you all and see that. But there's 2 things that can be done. One is I'm a professor at Penn State in environmental engineering, and I think I could create contacts for you with wastewater treatment plants that want to get those credits. The other thing is I think this is an ideal project for a lot of like high school volunteers to go out there and have fun on the bay for a day and animal and oysters kind of thing. I think this is really something that could, the thing that people really are concerned about, the environment and climate change and so on, is I know it's happening, but I can't do anything about it. So if you give people an avenue and an opportunity to do something about it, I think that would really resonate.
It's great. Yeah,
I totally agree.
Yeah.
Keep in touch.
Question, but I'll let Jake go first. So
Yeah.
go ahead.
Yeah, on that, but did the collapse of the bridge have any impact in the Chesapeake Bay area? Francis Scott Key Bridge?
Environmentally, I'm not sure if it did.
Yeah.
I'm not sure about that.
Okay. All right. I've got a couple of questions, and so I'll take my opportunity here. First of all, as many of you know, I live in Gloucester, Massachusetts, and that's got a long history of fishing, probably longer than anyone else in North America. So, and I'm sure that those of you in the field know the history of the conflicts between the Gloucester fishermen industry and along the northeast coast and everything. So lots of complaints from fishermen and vice versa, and a lot of battles. Well, 2 days ago, only 3 blocks from my house, there was a meeting where a Woods Hole scientist came through, meeting with a whole group of lobstermen and other fishermen here. And their purpose was to inform the community and start building support for an experimental program that you may have heard about already and weighed in, which is probably not going to start until 2026. But they're going to target things like the Stellwagen and the Georgia Bank and different things. But what they want to do trials on is a level of geoengineering with the ocean. Their proposal, if I understand it correctly, is to inject sodium hydroxide to the point of reducing the acidity of the ocean and supposedly find out for sure if this actually works, if it helps reduce the acidity, and if this has some consequences of capturing more carbon dioxide and different things or whatever. And so they're interested in understanding what the impact is on the environment. So this is a very new topic in this area, in this town, and people, of course, are very concerned what's going to happen here and what's it going to do. So I was wondering if you were aware of them and whether you had any initial thoughts.
Yeah, this it's kind of geoengineering. This is adding iron, which is potentially going to do a few things in the ocean. They've done some smaller scale experiments. I think again, this is sort of the thing that people like Terry and lots of people should be concerned about. Okay, this is not just in a box on the side. This is out in the big wide world. And at the same time, it also, I think, probably points out the seriousness that people are seriously thinking about this, and that people are seriously asking for permission to do this sort of thing. It's a little scary, but it points out how serious the issues potentially could be. I don't know scientifically. I'm not an expert necessarily on that slice of it, how effective or how well this might work. Matt's work does put substrate that has been pretty well tested and pretty well proven to be sort of environmentally acceptable in areas that are in open water. So, I mean, there are examples like this of moderate size. It sounds like the Woods Hole thing may be of a larger scale.
Yeah, I think I forgot which organization you represent. I presume he was NOAA. I don't know. But,
my concern is not so much, I mean, shoot, I do experiments, I try stuff like that part of it. Okay, I think we're curious people, that's fine. And sometimes we win. Sometimes we figure out something that actually works pretty well. That's okay. My concern is somewhere in the range of, are we playing God? And also a sense of sort of desperation that I like to think that a larger array of more modest proposals might be more effective than sort of imagining. I think part of it is also us, how shall we say it, punting our own responsibility down the road. Let's let the scientists figure out a fix so that we can keep doing the stuff that we're doing, even if the stuff that we're doing isn't really all that great. Instead of saying, hey, could we do things a little better in a bunch of areas? So I think that maybe that's just my comment. I don't really have any great scientific insight on that.
Okay.
Yeah, the CO2 is, CO2 in water is well known, and we've talked about it for 30 years, and it will produce carbonic acid. So it does depress the pH of water bodies. And even though the ocean is very, very large, it can in fact move the pH, a couple tenths of a point, which doesn't sound like much, but it is enough to make a difference for certain species. And again, maybe these would push it a couple tenths of a point the other way. It's not like it's going to turn the ocean into acid or alkaline. It's a very modest amount, but it could have an effect on some of the species that are affected by it. So
yeah, okay, yeah. I think they were saying that sodium hydroxide was being used in certain situations, and I don't remember exactly what it was. So they're wanting to scale it up a little bit and see what happens. My second question has to do, we were talking about the domestication of various species. What is there any general thing, or is it only species specific in terms of the difference in the shall I say the taste or the quality of a domesticated species versus a wild species? Now, there's been a lot of publicity about salmon, of course. I mean, people love to talk because that's probably farmed more than anything else. I don't know the numbers, but of course, a lot of people talk about that. Say, "Oh, I prefer wild." No, I prefer farmed, and people do about that. But is there anything inherent there that there would be a difference? Is that kind of generically true?
I'd like to tackle this one because I think there is some sense in which the wild animals that are carnivorous, so for example, the salmon, go out in the ocean and they eat all kinds, a wider variety of food than those that are grown in a place where they're being fed a certain prescribed diet. So that's the one where you say maybe the wild ones are a little better. It's funny, they do these taste tests and only the most expert taste people really can tell the difference. I mean, it's kind of funny. It's like you think, oh, like if I'm a fancy wine guy, I can tell you, oh, that one came from Southwest France, but I'm not. And maybe a couple of you people on here are, but most of you aren't. And no, you can't tell the difference between the cheap one and the expensive one. Same thing with the fish. But there are, potentially some differences and maybe even some health differences in the fat. So maybe the wild ones occasionally are a little better for your health in terms of some of the fats, some of the good, I'm going to call them good fats. The opposite of that is far more well documented, and that is that large fish grown in the ocean bioaccumulate things, and one of the more famous and really, really toxic things is mercury. And wild fish really should not be eaten in large volumes. I had a friend who actually ran a $2 million proposal, $2 million project, and tested all kinds of people. Finally, he tested himself. The federal limit is 2 parts per billion. He was at 4. And he's like, oh, I know, I got to cut back. I just really like those fish. Now, this is a guy with a pretty good head on his shoulders, so apparently he survived the mercury for some period of time. But mercury is really well documented to be really not good for human beings. And so whereas your fed fish that are fed a certain formulated diet have approximately 0.00000, there's no mercury in it. Okay. And so in some ways, the aquaculture fish are a more predictable and maybe safer. Certainly, let's say those grown in the well environmentally controlled places, the Norways and the US or places like that, I cannot necessarily lay claim to every country, because some countries have a harder time. But I think there is an argument for both sides. There's an argument to say, in some ways, each of them could be preferable. And at the end of the day, a surprising number of people can't tell the difference. So,
well, in that case, do you foresee good farming of swordfish and tuna? I love eating them. I'd love to eat more, but like you said, those are species that I really shouldn't eat as much as I do, or as much as I want to.
Cereola is now in development. It's not.
What?
It's not. What's the popular name for cereola? Matt's got it.
Amberjack.
Amberjack, which is one of the large fish that people like, and that they are growing at a modest commercial scale. I think we got to hold off a little while before we're going to see that in every grocery store. But yes, there could come a time where we actually have safer large fish for consumption. Yeah, we'll see.
Mm-hmm. Yeah. Okay. Fred, are you having your hand up again, or is that still from before?
I got another question, but I'm
okay. Go ahead.
If anybody else has a question, because
no, go ahead. No one else up.
Yeah. So, along with iron being the one nutrient that's limited, and that's why it makes it a desert, there's another issue that comes up with desalination of ocean water. You take seawater and you split it in half with reverse osmosis. Half is fresh water, the other has twice as much salt as it otherwise had. I'm under the impression that the dilution of that, if you were to send it back to the ocean, would be so great. It could, just by diluting it, the minor amount of increase in salt that you'd have would be so insignificant that it would not affect any fish populations if you did it right. What are your thoughts about that?
Yeah, we've talked about these with oysters, where you'd want to push the pH the other direction, the good direction, let's say, even though right now we're pushing it the bad direction. Locally, maybe in a bay where some of this very salty water is coming in, or where you're treating it with some other additive. Locally, I think you could have an impact. I tend to agree with you. The ocean is very large. And so unless you really, really geoengineer, and my sense is the Woods Hole stuff, it may have a local impact. And if they're allowed to do it, we'll all find out after a while. It's not like that's going to impact the entire world ocean at any time soon. So, yeah.
I'm thinking of off the coast of California, where you have, the huge circulation going on. What are your thoughts about that situation?
Yeah. Well, I mean, you have natural circulation. I mean, if they're talking about Georgia banks, that's Georgia's banks, that's also an area of upwelling where nutrients are naturally being pulled up, and it is a rich area. And it's also localized. I mean, you think of it as being very large, a couple hundred square miles, but like a couple hundred square miles out of many millions is not big. And California's pretty local. So maybe locally, there can be something that maybe could be positive in some way. I mean, you also worry about the other side, that what else are you messing with when you're... So I think, and I think scientists, when we're scientists here and people that are thinking about scientific questions, it is appropriate to ask these questions and to ask, I'll just say, all sides of these questions. So yeah, so I think the jury's out on some of that stuff.
You think more salt could be favorable?
Well, I mean, if you think about the salt in the ocean, you take the fresh water out, the amount of fresh water you're taking out is necessarily going to be the smallest amount of fresh water you can get away with, because it costs money and energy. Even RO, which is what much more efficient, is still a huge energy draw. So it's not like you're going to draw all the water out of the ocean. You're going to draw 0.00001%, and then you put the salt back in. And yeah, I mean, locally, it may be a little saltier in your bay or near your effluent. Maybe a culture system, might take advantage of that, where people put algae or other things, plants next to a power plant to suck in some of that carbon dioxide. So locally, you have a substantially higher number once you distribute that, the amount of change. I mean, you took that salt out of the ocean, you put it back in the ocean. Is it really going to change the salinity? No, not of the whole ocean, but maybe locally. So, yeah.
Okay. All right. Terry, you've got your hand up again.
So this is a more theological question, I think. Steve referred to playing God, and there was a reference to that in the paper in part of the discussion as well. I'm wondering if just to push back on that a little bit, what's the difference between playing God and being human beings in the image of God, where we're, called to do these things, having dominion of creation in the creation realm. Now, I want to recognize the importance of stewardship and the preserving sort of things. But I guess every time I hear that playing God idea, I'm wondering, is that really even possible? Is not every technological thing that we do just an application of that sort of creation mandate, where we're doing the things that God has called us to do with respect to creation?
Mm-hmm. Yep, that is a theological question. You're right, and a good one. Yeah. A couple comments. I think that you're right. I mean, simply by walking out our lives, we will have an impact on the world around us. And the Bible does, in fact, seem to put a special title on humans, made in the image of God, special callings to shamar and abad, to protect and serve. Obviously, that can also be abused. And I mean, the Bible mentions this 3-letter word, sin, and we are no doubt afflicted with it. And I think that is the other side of that coin, is that, yes, I should have dominion, I should care for the area around me, and I will almost necessarily always be tempted to do that so that it benefits me maybe more than God or my neighbor. And I think that's where I think, and that can be a healthy discussion, right? We should correct each other. And I think in the best case scenario, I mean, this sort of discussion is exactly, how do we know when we are simply doing something that God has gifted us to do, that is a good thing, that is benefiting each other, giving glory to God, benefiting creation, and in those cases, wonderful. And how do we know when? And sometimes, the common sense is sometimes surprisingly effective at going, no, I don't think that guy is just exercising his stewardship. I think he is accruing billions and billions of dollars to the detriment of other people and other creatures, and that's pretty obvious. So I do think that that other side of the theological question is there, is given our sin nature, how do we at least reduce our probability of doing things, I'll say, for the wrong reasons? But do we do things? Yes, we do. I mean, we've already got lots of people. We're already growing lots of animals and plants. I think there's no sort of like, how about we just quit doing aquaculture and agriculture? No, I don't consider that to be a realistic option. On the other hand, can we do it better? Can we be better stewards? Yes. And so how do we do that? And I think that's a more legitimate discussion.
Yeah, I would concur with that, Steve. I like the emphasis on motivation for doing things. To me, the phrase "playing God," I just shake my head every time I read that, because wait a minute, who's kidding what? I mean, failing to do something that you can do is also playing God. So it's like, whether you do it or not, what's the point? I mean, it hasn't been much of an argument for me either way. All right, any other comments, questions? Well, let me just say that I am very grateful to you, Steve, and your team for coming. This is particularly interesting to me, not just because of the town I live in, but I tend to be a pescatarian, and not strictly so, but that's my preference. And so getting these fish stock up there in a good way is a personal interest of mine. I love doing that. So, all right. So, thank you very much, Steve. And thank all of you,
everyone,
for joining
and thanks
us.
to my co-authors for being here. And have a great day. And
all right. Okay. Bye bye.